In this video, we're going to go over the topics that were discussed in Unit 3 that'll help you get ready for your test. So remember, part of what we talked in Unit 3 was about how to determine the best model for a data table. So you can see here, all of these tables have x that has a constant rate of change, right? So in all of these, x is going up by 1. So that means we can look at the pattern of the y values to determine the best model. So if we look at this first table, you can see that every time my y values are going up by 3. So I would say a rate of change of plus 3. And remember, if we're adding or subtracting the same amount every time, that means a linear model will be the best fit. So now let's look at the next table. So you can see here when I go from 15 to 8, I have minus 7. 8 to 5, I have minus 3. 5 to 6, I have plus 1. And then 6 to 11, I have plus 5. So it's not the same rate of change every time, but I can do something interesting here. I can look at the rate of change of the rate of change. So like from negative 7 to negative 3, there's a change of plus 4. Negative 3 to 1, there's a change of plus 4. 1 to 5, there's a change of plus 4. Okay, so if that second difference right there, if that's constant, that means it's a quadratic model. Okay, so a quadratic model would best fit this data set. Now let's look at the last table. So you can see I'm not adding or subtracting the same amount every time because like from 8 to 4, it's a minus 4. 4 to 2, it's minus 2. But if I look at the rate of change, you can see that I'm multiplying by 1/2 every time, right? So you can see there's like it may look like dividing by 2 every time, right? But remember, dividing by 2 is the same thing as multiplying by 1/2. So if you have that kind of rate of change where you're multiplying by the same number every time, that is going to be an exponential model that best fits that data set. Okay, so that's how you can look at data and determine whether a linear, quadratic, or exponential model would be the best fit. So now let's try practicing with a linear, quadratic, and exponential regression. So here it says this table shows the relationship between the amount of time students in a class studied for a test and their test scores. Create a linear model to best fit this data set and use it to predict the test scores of a student who studies for 4 hours. So remember, the first thing we need to do is go to Desmos and go ahead and create our table. Remember, the first row will be X and the second row will be Y. So I'm going to go ahead and type this in now. What I'm going to do is I'm going to click add regression, and then linear regression is the default. So I'm going to go ahead and round to the hundredths place, but whenever you're working on a problem, just round according to whatever it is that it tells you in the problem, okay? Or you can use your answer to match the answer choices, right? So if they're rounding to 3 decimal places, use that. Just adjust depending on the instructions in each problem. So now that I have my equation, I can use Desmos to predict the model, predict how the scores of a student who studies for 4 hours. I just click this little equation button right here. And then instead of y equals, I'm going to write f of x. And so once I have f of x equals this equation, I can actually just substitute in 4 for x. So I can just type f of 4 and Desmos will go ahead and just compute that for me. So you can see it's 98.57, but it looks like all these test scores are written as integers. So I'm just going to round that to 99. Okay, that would be the test score of a student who studies for 4 hours. So with quadratics and exponentials, it's going to be the same process. We just have one tiny little step that's different. Okay, so here's my quadratic. Here's my data table. I'm going to go ahead and create a quadratic model to represent the relationship between the number of weeks a company's open and their total profit. So I'm going to do add item and then do table. And then I'm going to go ahead and type in these values that I have. I'm going to do add regression. And the only difference here is that I choose this arrow and then I'm going to select quadratic. Okay, so now it gives me my quadratic equation. Once again, I'm going to go ahead and round, and I'm just going to round to the hundredths place. So I have 2.75x squared minus 0.87x, and then plus 15.22. Okay, so then what I'm going to do now is I'm going to export this equation, and then I have to, go to the front because this has a lot of really long decimals in it, and then I'm going to do f of x. And then it's asking me to predict the profit after 11 weeks. So I'm just going to write F of 11 in the next row. And that is approximately 338.4, right? So 338.4 million dollars will be their profit after 11 weeks. So once again, similar idea with exponential regressions, okay? So it says the table represents the number of clicks a YouTube video gets hours after it's released. Create an exponential model to best fit this data and use it to predict the number of clicks after 7 hours. So once again, top row is X, bottom row is Y, and I'm going to go ahead and create my table in Desmos. Okay, and then I click add regression, and then from the drop-down menu, I'm going to choose exponential. And then I have now Y equals 0.92 times 5.73 to the x. Okay. Now I need to go ahead and figure out the number of clicks after 7 hours. So I'm going to click equation. Instead of y, I'm going to do f of x. And then in the next row, I'm going to do f of 7. Okay. So you just replace x with whatever it's asking you to find. And so that video is going to get, let's see, 186,582 clicks. And then it does round it to the hundreds place in all of these values. So let's do 0.59. Okay. So that is the number of clicks that this video is going to get after 7 hours.